Okay, we're back with your math packet and we're on page 18 and this is problem number 1. We were working the second part of this problem where we were supposing that a polygon P, the measure of the interior angles of the polygon is what we're calling P, is equal to n, which is the number of sides in the polygon, number of sides, minus 2 times 180. We're trying to prove that that will show us the sum of the measure of the interior angles. So let's make a table. Okay, so let's come up with first a triangle, right? So I'm going to make a table that says sides, right? Number of sides, and that's what we're calling n. All right, and then we're going to have the measure of interior angles, right? And that's really the sum. So it's the sum measure. I just kind of put an M there. Okay, three-sided. We're going to draw a triangle here, right? Three-sided. We know that the measure of those interior angles is 180. A square, okay? That is made up of two triangles, right? It has 4 sides, and if it's made up of 2 triangles, that's 180 times 2 is 360. So the measure of the sum of the interior angles of any 4-sided figure is going to be 360 degrees, right? Okay, so this is a 5-sided figure, which is a pentagon. We just figured out that and it's true of any 5-sided polygon. Any 5-sided polygon, the sum of the interior angles is 540, and this is equal to 180 times 1. This is equal to 180 times 2. There's 2 triangles in it. This is equal to 180 times 3 because we can make 3 triangles from a 5-sided figure. Guess how many we can make from a 6-sided figure? 180 times 4, right? And we could continue to go on with that. So we're going to prove that this table fits this equation, right? So the number of sides is n. Let's try it with our 5-sided figure, right? So we're going to plug it in here. So the sum of the interior angles of this pentagon that they're giving us the idea of is, and we're going to try the 5-sided pentagon. So we're going to take 5 minus 2 times 180. Well, what's 5 minus 2? That's equal to 3 times 180. Now notice, that is exactly what we have right here. So this will work with any polygon, no matter how many sides it has. A nonagon, a septagon, a decagon, any of those. So you take the number of sides, right? And then you subtract 2 and you multiply that by 180, and it will give you that sum, the sum of the interior angles. It says check that this formula gives you the correct value for equilateral triangles and for squares. Well, equilateral triangle, just like any triangle, right, has 3 sides. The fact that it's equilateral means it has 3 congruent sides, boom, 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 but it also has 3 congruent angles. And if it's 3 of these, it would be 180 divided by 3. That means each one of those is what? 60 degrees in an equilateral triangle. 60, 120, 180. And that is still equal to 180 degrees. And we've already proven that with a square, we will get that same value. We have 4 sides, and we can make 2 triangles out of that. So that's 180 times 2, which is 360. All right, hope this helped you, and we'll see you soon.